Привет, здравствуйте.
Сейчас.
Так, я тут.
Да. Добрый
Здравствуйте.
день. Да,
Добрый
добрый
день.
день. Да.
Слушайте, у нас это как бы русский семинар. По-русски можно
It
говорить? Или как?
depends. Если придет кто-нибудь, кто
Окей.
по-русски не
Ну,
понимает, мы
без проблем, я
быстро,
все.
быстро переориентируемся.
Да.
Но пока вроде я знаю всех участников, и они понимают.
Я еще Сергею Соловьеву переслал. Может, он придет. Ну, может,
Да,
и
но он
нет.
тоже понимает.
Да. Так, и мне надо будет поделиться как-то экраном. Я могу,
Ну,
нет?
попробуйте.
Ага.
В принципе, здесь все участники равноправны, и так что
Мгм.
с самого начала, по-моему, каждый может.
Так, ну, вроде, да, делится. Так, пока
Да.
выключу. Ага.
У меня почему-то воспоминания из каких-то давнишних времен, что я видел школьный учебник русского Евклида, который переведен, ну не переведен, а пересказан был таким человеком, ну, в общем, он был издан в каком-то греко-латинском кабинете имени Шичалина.
Ну, наверное, самый...
А кем он был переведен, я не знаю.
наверное,
Вот, но я пытался его
Щетников,
найти.
наверное. Наверное, вот который переводит этого
Нет,
самого, нет?
Щетников он переводил Прокла.
Да,
Это
ну, по-моему, единственный
известно.
математик, которого я там знаю в этом
Да.
кругу.
А он умеет по-гречески, понимает, или он его переводил как-то так не
Не, ну
по-настоящему?
понимает, там какая-то была, так сказать, критика вот со стороны знатоков греческого, которые там
Да.
высказывали вроде серьезные претензии,
А,
но как бы что-то он знает по-гречески, да.
да. Нет, я в какой-то момент Вандерварден в книжке как-то «Возрождающаяся наука» или что-то, там
Да-да-да.
вначале есть объяснение, что вот как же можно ли писать такую книгу, не зная греческого языка. И он объясняет, что вот, собственно, есть прекрасные переводы на, ну, на какие-то, не знаю, на какие языки европейские, и даже если такие же переводы для латинских книг, но для латинских книг в этом нет необходимости, потому что даже приятнее читать в оригинале. Такое
Нет,
его
ну вот мой
объяснение.
личный опыт с этими языками, я, так сказать, не
Да,
отношусь к числу знатоков, но вот как раз Чалин меня учил там и греческому, и латыни, все такое.
да,
И вот самый опыт у меня был с Аристотелем, что его вот, ну, в каком-то смысле реально проще выучить вот его этот греческий, к тому же он сам там придумал свой язык более-менее, вот, чем разбираться с переводами, потому что там просто вот невозможно перевести, ну, чтобы, например, термин совпадал с термином. Это... Хотя можно вот как бы пересказать. Есть издания такие, еще старые, такой Росс был англичанин, и там не перевод, а вот у тебя греческий текст.
sorry. I just see some name of
Окей.
a person, of a new person. Just let's check whether we should speak in English or you understand Russian.
Hello.
Hello.
No, I don't understand
Oh, no,
Russian.
okay.
Okay,
So
no
we switch to
problem, no problem.
switch to
Okay.
English immediately.
Yes.
Yeah. Yeah. No. I think that Aristotle is hopeless in any language because it doesn't make any sense in any language. But for other people,
No, what is really accessible, if you have Greek text, you don't need to be an expert, and you have a English paraphrase, and then
yeah.
kind of analysis of difficulties, and it works. It simply doesn't work if you want to make sentence to sentence. That's
Yeah.
hopeless, but
Yeah.
it's in a sense not needed. There is no reason.
Yeah. Yeah. Okay, Коля, we see you.
Да, здравствуйте. Очень приятно.
But we didn't hear you. Don't hear you.
Да.
No, not yet.
Okay, good evening.
Good
Good
evening.
evening. Yeah. So the idea we have today a kind of non-standard talk. And the idea is, there is some part which I cannot say in English, but it will be just introductory part. В путешествии из Москвы в Петушки есть такое место, что все говорят Кремль, Кремль, а где этот ваш Кремль, вы никогда его не видел. Вот точно так же все говорят Евклид, Евклид, вот там 2000 лет изучают геометрию по Евклиду, а что же там интересно написано? And so we will try to just to get some kind of idea what is written actually in Euclid's elements. And so the first, there is question, historical question. So how is it really some fixed, more or less fixed text which was in use during all these 20 centuries, or how it came to us, how we know it, why we know it? And the second question, what is really written there, and why can we understand what Euclid really meant, and why he used this argument and not that argument? So I tried to read Euclid and was very surprised of what he is doing. So sometimes it looks completely logical why he does this but not that. Sometimes there is some theory explaining this, but still rather strange one. So it's interesting to hear what the experts in history of mathematics can explain about this thing. And so we invited Andrei Rodin, who is a historian of mathematics, among other things, and will kindly agree to tell us a bit about the history and the contents. Okay, so you can share.
Start? Yeah.
You can.
Okay, what actually I prepared to do, I made some set of slides just to introduce the basics, which I think important. And then we simply open edition. I may comment a little bit and probably you ask questions and we consider that way. But probably before we start, I make short remark, which I did not include in the slides, about this methodology that just Sasha mentioned. This is between kind of historical reading of, say, ancient mathematical texts. It applies not specifically to Euclid, to everything, versus kind of contemporary reading, right? When we kind of read into our today mathematical understanding. And there was a long discussion about that. Actually, part of that discussion was in Russian in математико-исторические исследования. There was this, books, the whole series. The discussion was started in 1970s by Sabbatai Unguru, Israeli colleague who died recently, last year or before the last, I think, and who was actually champion on this kind of attitude that we should not modernize Euclid. We should kind of, read it verbatim. And that's, of course, the position that if you push it at the limit, it becomes absurd. So it just, what it means, you should learn Greek, whatever, and simply kind of preach, the whole line. You have no right to think about that. But the opposite position, in a sense, it may be also pushed to absurd, just as you see some ancient text, and then you make your kind of up-to-date mathematical fantasy that has no actually obvious relation to what you read. So of course, kind of right position is somewhere in the middle, but I think there is really no general rule. At least I don't know. I kind of thinking about, but there are good examples, people who do it very well, in my opinion, and many other people. By the way, students of Sabbatai Unguru, Leo Corey, and I forgot first name, Nets. Corey is in Haifa and Nets is in Harvard. I think they are doing absolutely excellent job of that sort. And I don't know how, so I don't know, general rule is in a sense is in the art. Okay, that's just general remark.
Yeah, but I want to say, just if you say this, that I think that the most interesting position, the third one. So imagine we are with our modern knowledge, we are moved to Greece, and we have to pass the exam to personally Euclid in 2 weeks. And then we should understand what is written there. Of course, we didn't forget our knowledge, but we should understand. Still, we have to answer in a way acceptable to Euclid and behave naturally in his sense. But for this, we need to understand what is written, what we should say, what we should not say, what is forbidden to say, and so.
Right.
It's okay.
Right, exactly. So here, just my slides.
Yeah.
Is it visible? Everything right?
Yeah.
Okay. Okay. So first, just very general background, then more about text, and that part probably I combine with just reading into the text. So background about the author, very little is known, except that such person existed. It's a real historical person. So he's acme. Acme is a, if you don't know, standard Greek term, sometimes used also in modern languages, is kind of top point, flowering, расцвет, you would say in Russian. So it's somewhere between Plato's death and Archimedes' birth. And that was the reign of Ptolemy the First. And geographically, actually, most of his life was spent in Alexandria, which is Egypt back then and also today. That was then recently founded actually by Alexander the Great. Right, and there are some anecdotes like no royal road in geometry, except this anecdote also told about other people. So it's not very informative, actually. Right. I want to mention, just to give a concept, that Elements is not the only work by Euclid, and actually not only extant work. There were also data, very interesting, but okay, I just mentioned, okay, if you want to ask, I made this couple of works.
You mean the work which are really available now? It's not that he wrote and that lost.
Five. There is more which kind of pseudo Euclid, so people not sure it's Euclid or not, but about these five, everybody's sure. Optics, very interesting because it's kind of applied geometry, if you like, right? It's not pure geometry, but it applied, and astronomical treaty phenomena. Basically, it's kind of, you would probably not say it's really spherical geometry. There is a discussion, and that's a separate issue, but at least kind of spherical astronomy. Right, then there are lost works which are mentioned and sometimes available in some fragments, in paraphrases. So he also composed the Book of Conics, one which is available is by Apollonius, but earlier one belonged to Euclid. Then there is this interesting, but unfortunately not available, about fallacies in mathematical reasoning. Then there is also a little bit cryptic porism, because nobody knows exactly what porism is, but should be something between problem and theorem, and I'll tell more about problem and theorem later. And then there is also kind of intriguing surface Loki, kind of geometrical surface two-dimensional, say, locations, places, topoi. Right, so it's kind of theory of surfaces, which actually not, we don't know much about theory of surfaces in Greek mathematics, so it also sounds intriguing, but we don't have anything, nearly nothing except the title. So
what's the book
Elements.
data? The book data, what is it about? It's about?
Data is basically about something is given, right? No, as we say, given a point or lines, and what you can do, you cannot do given something. So it's close to the element, but it's kind of logical form, I would say, which is different. It's a specific kind of problems, right? No, many problems in Euclid of the same sort. Given a line, construct a regular triangle, but then it's more, I'll say, detailed study of what you can or cannot do given certain data, geometrical.
But it exists in English or in Russian?
It's I'm not sure about, no, I don't think in Russian it does exist in English.
In English, yeah.
Right. What was translated. Okay, so now to the elements. What is the title? Title means alphabet, stoicheia. By the way, Russian word stichia or stichi comes down to the same word. It means something like elements. Elements is just Latin rendering, Latin translation. But basically, the how to say, immediate literal meaning is alphabet. So it's kind of ABC of, I think about like 20, 30 years ago, that was popular. Now probably less popular, this kind of books, ABC of, I don't know, cooking or something, right? And so that's that sort of title. Right, and another historical point is that actually Euclid's elements, certainly that we may say we know for sure, were not the first elements. So they were like predecessors to Euclid. Proclus, at least he mentions at least one. Proclus is a Neoplatonic philosopher who wrote extensive commentary on first book on Euclid in 5th century, which is a very important source for all of Greek mathematics, because also he actually gives a fragment or paraphrase of otherwise lost history of Greek mathematics of contemporary to Euclid, more or less, Eudemus, because that's what makes this commentary very valuable historically. But also, yeah, there are a lot of some interesting material. Yeah, then we may discuss how much it's interesting or not. But that's, I think, important point, right? That Euclid was not like inventor of this whole idea of elements. Of course, it goes without saying that the content was not invented by Euclid, right? It's kind of composition, it's kind of encyclopedia of existing mathematical knowledge. So probably added some theorem that we don't know. But anyway, that's not kind of work of single person in a sense. It's rather a label. Right. Right. And now I'll coming to the text, and I'll begin.
Yeah, just some strange question. So, can you estimate how many copies of this book were not printed, of course, but created in Greece? It's like 100 or 1,000 or 10,000 or what?
Oh, yeah, I read it. No, here, of course, I'm not best expert, but first there were no books, of course, right? They became books rather late. I think this Biblios was invented sometimes later.
No, I mean they have rotating things in
yeah,
I guess
a little bit. Yeah, they had some technology, and okay, now I'll say more. What we have as a kind of best known estimation to what was Euclid originally, but of course it's not absolutely precise. It's kind of hopeless to think what was exactly the text, say, written by Euclid, because it was multiple. No, of course it's not like even hundreds. It's rather tens, right? It's rather tens. No, again, it just depends of concrete period of time, right? But frankly, I'm not really expert in this early, because here you need really philological expertise. So I read something.
Yeah. Just what people think about this, I don't know.
This person who knows most of anybody is Nets in Harvard. That's I know whom to ask if you.
It's not really important.
Right.
Just
and that was another very important, say, expert who spent all his life, John Mordek, also in Harvard, if I'm not confusing, right? Who died, say, recently, already almost 15 years. So he told that any attempt to plot the course of Euclid's elements, meaning the course of the text exactly, from the 3rd century BC through the subsequent history of mathematics and science is an extremely difficult task. No other work scientific, philosophical, literary, has in making its way from antiquity to the present fallen under an edited pen with anything like an equal frequency, and with good reason. It served for almost 2,000 years as the standard text of the core of basic mathematics. Here, actually, okay, I'll explain later. I have some reservation about that's often repeated phrase. And as such, the editorial intention is constantly received was to be expected as a matter of course. So I'll try to, explain this in my own words more, because I think it's really important for understanding what is Euclid's element. So the thing is that these copies or reeditions, right, this transmission process that somehow brought this text from Euclid to us now is actually rather different from what we see, say, in philosophy, in Plato, Aristotle text, or in Sophocles or literature or whatever, right? And the reason is rather clear, because mathematicians' attitude, just as today, right? As Sasha, you immediately try to say, no, that's wrong, that's I do this. And I think that's absolutely typical and say for mathematicians of all times, I would say. It's not just today attitude. It was an attitude, I think, as far as we can see. It's something really about mathematics, and effect of that was actually very rarely people who copied these things, right, really try to preserve the text. They rarely try to, they normally try to improve on it, right, to do better, to kind of correct what they would say mistakes and errors, right? So it works that way, with some rare exceptions, thanks to which actually we do have, after all, something like this text, and right, it's what I already say, and right, and so let me. Now, I say, what is this text? Is kind of best approximation that there are reasons to believe is best. I'll tell a couple of words about it first, and then I'll say a little bit more about this transmission of this rewriting process during, the centuries. So, yeah, I called it Urtext. Is actually musician's term, which, musician, it's a German word, and they use it for Bach scores, for example. I don't think that my, colleague historians use it, but I do. I think it's good, like Urtext. What is here Urtext? Yeah, the answer is this. So it's, you see, it's late 19th, beginning of 20th century. Thanks to efforts of Joachim Heiberg, who was a Danish philologist, not really mathematician, philologist, and his assistant, Heinrich, I think, Menge, right? So they did, actually, it not the only thing that they did, they also did Archimedes and something else, maybe more, I didn't see. And actually, Opera Omnia, so it's full collected work, complete collected work. And what is meant is the Greek text, of course, along with New Latin translation, they produced rather for, I would say, technical reason. Right, so one of these volumes, probably the first, I can now forget, is Elements, and then the rest. So all Euclid, we are reason believe we have in kind of reliable sense, just this edition, which is a little bit more than 100 centuries. Then, of course, Heiberg had this rather complicated, I would call, philological proof how he came to that text, how he believes that it's the best, say, approximation to the original text, and I cannot reproduce all of it. It's rather involved, but the basic facts that there was edition in Alexandria, so the very place where Euclid was around, made in 4th century by Theon, Theon Alexandrinsky, we say in Russian, Theon Alexandria, who was a mathematician. He also known for some other things. But one of the things that he edited Euclid, right? He composed elements in some form, and then actually via, of course, a lot of other steps in transmission, which I'll a little bit mention just in a minute, served to this edition of already 16th century in Europe, thanks to Simon Grineus, we say, and that's called by philologists editio princeps, meaning kind of, again, something like urtext, foundational text, but based on Theon. But the problem
this was in Greek, I guess, yeah?
Yeah, we are just talking about Greek text now.
Yeah, so in 1533, there was a printed edition, yeah?
Yes,
and the copies of this edition exist up to now.
No, of course, in libraries. Also, I think I do have them in my computer.
Yeah, but the copy of Theon's edition don't exist. We know it only because of some chain of things. But for Grineus, we have just exactly the same book that he can get in his hands.
No, we do have Grineus. I think.
Yeah.
I didn't keep it in my hands, frankly, but it should be in some.
No, of course you cannot have a book of 15th century. It will be too expensive.
No, you can. If you come to École Normale Library, you just take from the shelf books of 15th century.
From 15th century. Oh, yeah.
Yeah, and by the way, in Moscow, it's called Muzей Книги. There is an excellent collection of old books, just nearly full 15th century. Yeah. So no, it's these things somehow available, but not Theon. That's right. Right. So that's the story about establishing of Greek text, right? So the problem with Theon, and that was situation, say, before Heiberg. So that's edition would count as kind of standard edition for Greek text. But problem was that Theon himself, he mentions elsewhere, actually in commentary to Almagest, to Ptolemy, that last proposition of 6th book of Euclid, of elements, is just his own. So it was clear that, like many other people, he somehow, he tried to modernize Euclid's text, so it was not kind of, ultimate reference. And actually in the beginning of 18th century, I think he was just an amateur, he discovered a manuscript without that proposition. And so Heiberg actually, he based all his argument on the idea that that particular manuscript, which was different from all other known manuscripts, which, by the way, normally dates something like to, I think the earliest physically available manuscript dates back to 9th century, right? But then there are, of course, much more. And unlike all other manuscripts, that manuscript did not have that proposition. And so on that basis, Heiberg somehow came to the conclusion that it derives from some earlier sources, not Theonian.
And this is also, of course, a Greek manuscript. It's not a translation.
Yes. We are talking about Greek manuscripts. Yeah. Right. So that's how, Heiberg did his work. Then actually already in his lifetime was kind of a position, kind of different approach by Maurice, I think, Kolmogorov, who argued that actually we can do better with Arabic translations, that probably some Arabic translations actually were made from better, Greek sources, which were lost. And so a better way to reconstruct the original text would be rather via Arabic translation. And that discussion still exists today. Sometimes some people, I've seen recently, a couple of years ago, a paper that kind of continued that argument, but say consensus, kind of philological consensus today is that this Heiberg text is the best we have.
And how different they are. For example, if you just take, I don't know, proposition 7 of book 3, just I take the random number.
Yeah.
Is it the same in all these manuscripts, or they have different numbering?
No, already numeration, many things are different. And it was actually a couple of years ago, this Congress of Historians of Science, and I attended session when people work further on manuscripts, and there is kind of mess in these manuscripts. It is really very difficult.
So actually the numbering which we have now, it goes from Heiberg, or it exists in other books also.
No, it's existed in some manuscripts, right? But what he did, Heiberg, he compared many manuscripts. And these many manuscripts, actually, he looked into all available, at least Greek manuscripts, right? And then actually, this particular manuscript that I just mentioned of Vatican, it's just unlike all others. And he developed argument that it's, in a sense, more reliable than others, but on the other sense, it's not like you cannot just disqualify all others and follow that one. At least it's what not Heiberg did. And I say there is if you want, we may just look together, but it's rather involved argument. And,
okay.
And purely philological, historical, right? That's, so I just give a sketch and I read that, but I don't really know.
So just in general, it was the same
what
time.
is actually going on during these recent years, right? That people really work more on Arabic manuscripts, which are multiple, it's a huge corpus sitting in a big part in Institut du Monde Arabe in Paris. Which is not, say, studied at the same say degree as Roman and Greek, say, corpus. So there could be still some, and the people, usually researchers, they don't just challenge the whole idea.
No, I just want to understand some basic things. For example, during in the Roman Empire in the 3rd century AD, they have an Latin copy.
That's exactly what I'm going to say now. So it's of course very, very sketchy, right? Otherwise I would take all the time. About transmission, so it's just before 15th century, so it's quite a lot, 18th centuries, right? And it's so-called Greek Romanian phase, one translation which does not really exist as something like version of Elements, but which certainly existed, and there are some fragments, is due to Boetius, who made probably first, I'm not sure, but Latin translation, sometimes in the 5th. No, actually, that was rather late work, so it had to be already 6th century, I think. It's more or less, he did it during his time in prison, when he wrote this Consolatio Philosophica, Утешение философии. Right, it's quite an amazing character by himself. Right, so he did Latin translation. Probably was first one, probably not. I'm not again, right. So that's, then of course in the end of the empire, right, there were some Syrian translations which were important. in Syriac language. And there is a lot of things that's Leo Corey who knows that stuff the best. Better than me, certainly. And then, of course, was this huge corpus of text, which we already discussed a little bit, so-called Arabic. It should be understood Arabic is a language which used like Latin. That does not really reflect ethnic origin of people at all. All right. And also, by the way, Persian was also used at certain point, but Arabic was standard scholarly language in this year of the time. And then there is a huge corpus of text, of translation, commentaries. Actually, they developed quite a high culture in the sense that they really made difference between, say, translation, commentary, or kind of paraphrase. That they had kind of classified what they did with Euclid, something what was not done in Europe until recently, actually. Yes, right. Again, the word of Murdoch that he says it's mathematically most creative of all. Here, I think it's interesting, and it's a little bit pity that it's kind of still difficult to access for mathematicians, because that would be really interesting, right, to evaluate like from mathematical point of view, because he still was not really a mathematician. But yeah, very likely he was right. So was this so-called Arabic phase, and then was exchange between, actually it was related to the to the Ottomans coming to power in Istanbul, right? And then there were refugees. No, actually exchange started earlier. So first Latin translation in Europe were made through Arabic, not through Greek, but from Arabic. I think first one was in 12th century. I can give precise reference.
No, just the general picture,
right.
Yeah.
Yeah, but later when Ottomans came to power, it was 14th century. Yeah, I'm not
probably
very good for dates.
When the Constantinople was taken.
Constantinople, right. And then actually what happened that first in Europe, it was believed that Greek texts are lost. So the only available sources would be Arabic. But then actually refugees brought it from kind of hidden libraries, you know, this Greek text, and was a new wave of translation already from Greek. And right, I think that, right, that's already mentioned. So that was a principal, editor principle, and I think that one was a first, or at least first kind of standard, later became standard, translation from Greek, right? But at the same time, say in Venus, already 15th or early 16th century, you had this kind of Latin versions, which were very far from original Euclid. And there was actually some competition between these two versions, and mathematicians would normally simply not care about this editor principes, which was philological work, right? Because that was already reflected, both of these reflected kind of new ideas, algebra, you know, and stuff, right? Then was very influential Clavius, Euclid, but again, it's not really Euclid. You see, it's more than half he just made himself. So you see, it was called Euclid, just it was like a brand. It was not really a text or an author. Right. This Clavius was very influential also here in France and all 16th century. Then it's already 17th. That's, I just put here curious example I came across personally. So it was Andrei, should be one. It's not. Andrei Taquet, also 17th century, mid 17th century. And so first it published just as a geometric book without Euclid on the title, but on this re-edition already in 18th century,
Yeah.
it becomes Euclid, you see. And really, sometimes there is no apparent reason why some people use this brand Euclid, other people don't. So, yeah, and that's also kind of curious example by Isaac Barrow, who, in a sense,
Newton's
sometimes,
teacher.
yeah, sometimes his context was really teaching, but yes, that person, exactly, right. But he had this strange idea, so he was concerned about kind of pure Euclid, because he was very upset by what he believed as all these mistakes, illogical, everything. But he believed that the best way to get back to original Euclid is just forget all this manuscript, all this philological stuff, just rewrite it anew. And that's what he did. But he somehow he really writes there that that's my way to get back to Euclid. Just to write it from the scratch. Right.
Yeah.
And that's, of course, very important work, already known for story of non-Euclidean geometry. That means Euclid's corrected from all errors, omni naevo vindicatus.
Yeah.
Right. So it's kind of telling title again. Right. And in 19th century, as Murdoch says, was avalanche of Euclid's primes, frequently radically divergent from any imaginable text of the elements. And that's famous edition, which was one of first example of color printing, and not really first, but first kind of in mass production, I guess. At least they wanted to demonstrate how they can print colors, and was recently republished by
It's unbelievable, by the way, that the guy created all the macros needed for that, probably later, and reproduced this nice letters on the beginning. And he has an English version, Russian version, which you can generate with special parameters.
Really?
And also he has a version with letters or without letters. So it's just a kind of meta book for which you can generate different versions of this Oliver Byrne.
Yeah. I had the privilege. I was actually in the library, invited by a guy, I forgot his name, shamefully. He lives not far from Zurich. And he gave his exemplar for that, for Taschen, right, for that work. And he wrote also a short introduction. And actually, he offered me even this thing, and it's sitting in my now kind of remote apartment in St. Petersburg. Unfortunately, I couldn't. It's kind of heavy. It was right. Now, I just mentioned translations. That's also interesting because that's English translation, but was made from Heiberg, right? Because there were, of course, a lot of texts which say this is Euclid's element, but as I just stressed, it's not really Euclid, right? Also were some Russian editions, but if we are talking about translation from Heiberg text to new languages, no, I just mentioned these two. The first one was made into English, which in the beginning of 20th century was not kind of expected, right? People would rather expect in German or in French. In French one, by the way, only recently is finished, the last tome. I think last year, just very recently. It took a lot of time, preparation. And we have this Russian version also made during the war, actually, most part of it. So if you want, I can say more about Mardukhai Baltovskoy, because that was my dissertation. I wrote about Euclid, but somehow I worked in his archive. And
let me make a wild guess. So he was an old Russian professor who struggled under Soviet rule before he found some job that he can do in accordance with Soviet authorities, which is translating Euclid. Is it true or not?
Yeah. No, it's actually more than that, because his family, you know, Kalinin, как вот это,
Mikhail Ivanovich.
Mikhail Ivanovich, yeah, right.
Yeah.
He was his babysitter in his youth, you see, in St. Petersburg.
Yeah.
And father of Dmitry Dmitrievich gave to this guy money and everything to bring him to the university, Mikhail Ivanovich. And that was the reason why he protected him as far as he could. Mikhail Ivanovich protected Dmitry Dmitrievich. But at the end of his life, it still somehow went worse. Mikhail Ivanovich's wife was in Gulag, as commonly known, and actually he started his career in Warsaw, which was Russian university at the time, of course, right?
Yeah.
And then during the First World War, this Warsaw University, that, by the way, interesting part of the story, which still not studied, was moved partly in Rostov, partly in Moscow. And actually, archive of Warsaw University is still sitting partly in these two places, and I think would be really good project to, you know, collect it or whatever. But now it's not good moment to do that, right?
Yeah.
Right. So we have at least one Russian translation of this, right?
And also there is an English translation of Fitzpatrick. I think.
Yeah, that's what I'm going to use. That's kind of it's more recent. He's very interesting character. I never met him, but he's teaching quantum mechanics. He's doing this job. He also did Almagest just as a hobby. But and I think in the community there are some, he's not really part of this community of scholars, but as far as I could see, it's all good. I mean, it's not so different from Heath. He just modernized a little bit the language.
But he also retyped all the Greek text, I guess.
Yes. Yeah. He just has his Greek text.
No. You need to enter this in later. So probably he did it himself. So it's a big job in it itself. To prepare a new edition. I guess old editions.
No, I don't think so. He did it himself because it actually was a project started about it's more than 20 years ago, called Thesaurus Lingua Greca.
So someone else. Yeah.
The problem is that nobody really checked because many people now use it, but I don't know, maybe I didn't follow some recent stuff, but myself, I was concerned whether this, and that was made by a group of young German, postdocs who really put all corpus of Greek and Latin texts. It's not so much, by the way, in terms of like megabytes. But they put just all into one electronic base. But the problem, and which is great, it's searchable. You find.
But they were not mathematicians, but at least. So they know all the Greek letters and can distinguish between them. That's very important.
But problem is that if they did some, mistakes,
nobody will find this.
Now it's really difficult to detect because. But probably it's done something about that. That's I don't know. But of course, all these electronic versions, they exist in some form. Now you can read classical editions, and that's not a problem. Right. So kind of conclusion of this part is that basically only with Heiberg historical edition, right, we have really this split, which I think is reasonable and good, between, say, historical study of Euclid's elements and all these transformation modifications, right, and kind of rewriting Euclid, which in a sense still continues, right? It's of course, different big topic, but we may quote at least two things, like Hilbert Foundations of Geometry, which is kind of model of modern axiomatic method. Even it's different kind of work, right? It's not supposed to, how say, to cover all contemporary mathematics. It's just kind of example, it's kind of toy example. In a sense.
Yeah. But actually, it's clear. But actually, I should say that if you try to, Hilbert is a bit like Euclid now, because if you try to read the chapter about geometrical construction, it doesn't make any sense. So we need a special historical research to get what they thought at that moment about these things and what it is. But it's another story.
Right. And then Bourbaki, of course, who kind of explicitly, I think it's in this manifest architecture of mathematics, that they kind of had Euclid in mind, right? And that's how they made their title. So that's kind of even more radical ways, of course, rewriting Euclid, if you like.
Oh, yeah, okay, but I think it's if you speak about Euclid, I think it was Hadamard in France and Kisselev in Russia who tried to write something really for school, for the first study. Neither Hilbert nor Bourbaki was intended for first time learning.
I think that's a bit different story. Already Kisselev actually derives from, in my understanding, correct me if I'm mistaken, from Lagrange, right? And
probably I never have seen.
In Lagrange textbook, even if, of course, it's very close, there are kind of ridiculous things which are just taken from Euclid, but at the time, Lagrange textbook was supposed to be kind of in a position, right? Because there were people who tried to keep Euclid, of course, meaning Euclid, not really Euclid, right? And then there were this new wave of people, I forgot earlier, no, more or less related to Encyclopedia d'Alembert and Lagrange, who said, okay, we should rewrite. We don't need all these axioms. We need something practical. And Lagrange was part of that. And Kisselev just derives from Lagrange, just Russian version of Lagrange, more or less. In my
not from Hadamard, because Hadamard maybe was even later than Kisselev. Okay, but they are rather close in spirit, I guess. But Hadamard is more advanced.
Actually, it's kind of continuing story, because similar thing was, of course, in Russia. In the 19th century, there were kind of pro-Euclid people and kind of anti-Euclid people, like Lobachevsky was, by the way, anti-Euclid, and actually anti-Euclid meaning anti-axiomatic method. Lobachevsky kind of hated all these axioms, and that's right. And also in Britain, of course. And there is this marvelous book, more probably you know, written by what first name Dodgson, known as Lewis Carroll.
Lewis Carroll,
right, called Euclid and His Modern Rivals. Did you see that? No. It's kind of written as a dialogue about that's the same sort of dispute in, say, pedagogical community. Some people were for Euclid, and some other were against Euclid, and then he has a kind of dialogue. I can send you. I have all the story, but also funny thing that if you read Euclid, when I first came across, I thought was Euclid, but actually I even found in Bodleian Library in Oxford kind of notes made by Lewis Carroll, and that was his version of Euclid, but of course it had nothing to do with Euclid. It just was right. So right, and the last point I want to make is that, at least in my understanding, in my suggestion, that actually this kind of pursuing original, probably it's not, how to say, the best model of this kind of historical research, because already I mentioned Euclid's Elements was not the first element, right? And what I think is really important, that all this historical process, if you like, right? All the stages of rewriting. So it's not original. So we should not be fooled by this idea that we find kind of you know, Saint Grail original.
Oh no,
Euclid.
of course, but it's much more difficult because, for example, if you read this comments of Mordechai Baltovsky, and he tries to explain what is the connection of Euclid with contemporary mathematics, but
Right.
contemporary mathematics in his language includes. Uh, for example, he speaks about actual infinity, and infinity is small things. So but you can also write a lot of dissertations about what Mordechai Baltovsky believed, but this is probably not
Right.
that.
But also what he tries to do, he tries to search in a kind of different textbook or Euclid-like books, what happens with this definition, what happens with that, but that's of course very fragmentary. And now there is some more about that. I have a colleague, Vincenzo De Risi, I think he's the best specialist. So he tried work out some Sakeri, for example, right? Some links. But I think we
Yeah.
really don't have this general picture. And I also don't think we can get it just through traditional philological methods. So probably we need kind of put everything into computer and whatever, do something, you know, more serious with a big corpus of text. Because simply, I try to calculate that normally just 2 PhD students go to Institut du Monde Arabe in a year, and they search something for their little thing, and that's hopeless. You would never get a kind of grasp of this corpus in that way. So you need to do something something different probably. Right. But that's just kind of dreams and fantasies. Yeah, and I also put I'm sorry, I don't know, Voevodsky, because actually at least part of his motivation of his so-called Univalent Foundation was to update Bourbaki, so kind of made kind of computer-based and kind of computer checkable version of Bourbaki. So in a sense, it also connects to Euclid via Bourbaki. But okay, that's of course very different, right? That just I put some beginning of Hilbert and Bourbaki. Yeah, we know. I used to teach his grandson mathematics.
Oh,
So
yeah.
I a little bit know the family. You know, it's partly Russian from, no?
No.
He had, I think, a wife of his son was a Russian who made it through Manchuria to France. So there is a lot of interesting connection.
Yeah.
And you know how he died? No?
No.
No? He was swimming every month or whatever in Siena in Paris. And how he was already nearly 90 when he swam, I think, in February. And so, yeah. Otherwise, he would come to École Normale bare feet. And no, it was just amazing.
No,
amazing
actually,
person.
Kolmogorov almost died in this way because he was swimming in Moscow when he was like 70 or 65 or something like this. He went to Moscow River and in the winter and start swimming there. But then he found that when he tried to get out, the part of this place when he came in become covered with ice. And so it was very difficult. So he told that at some point he thought that he cannot, but then suddenly he managed to get out somehow.
Yeah, fortunately. Right.
Yeah.
Right. Okay, so here I just have something about structure of problems and theorems, but probably I can go to the just text of
just to get some idea what is inside.
Yeah. Right. Just this thing. Just a general description before we go to the text. Which book contains what? So we have this book 1.4, which in a sense is separate theory. As historians normally say, it's kind of the most archaic part of that. It's kind of separate treaty. right? Where you have this funny notion of equality of, so kind of, I call it basic geometry rule or compass. Then you have a theory developed that's well documented by Eudox. It was contemporary of Plato, right? So it's 4th century before Christ. And so here you have this notion of proportionality and this geometric theory of proportion, right? And then you have arithmetical book. There are 3 numbers which are formally independent from the rest, except that axioms also apply in arithmetics.
So
Right?
Euclid algorithm is there.
Right. Euclid's
GCD.
argument is there. And also you have a arithmetical theory of proportion, which in a major part simply repeats geometrical one.
But for integers.
Right, he does not have any other number but, say, positive natural numbers, right? And actually, first natural number is 2, is not 1, because 1 is not a number, is kind of Bonadas, and then you have right, and that of course many people comment that kind of original idea of Eudox could be something like algebra, right? Something like saying that theory of proportion could be the same theory both for geometrical magnitudes and numbers. But in Proclus, for example, Proclus says from like himself, first person, it's not sufficient reason if we have this formal kind of similarity, right? It's not a reason to unify the theory, because here we have just different subject matter. Here we have a geometrical magnitude, here we have number, and there is not this abstract. That's an interesting topic because also Aristotle discusses that, and there is a lot of interesting stuff in Aristotle concerning this notion of universal mathematics. Actually first found in Aristotle, and it refers to that, whether or not it is justified to make kind of general theory for which geometric theory and arithmetic would be special cases. And Aristotle answer is no. You should.
But Aristotle was after Euclid or before.
Aristotle is actually is older, of course, than
so he doesn't learn geometry using elements.
Right. But at the same time, of course, there's a kind of what we find, and particularly in the book 1.4, but also 5.6, right? Because Eudox is older than Aristotle. So
no, I doubt that
mathematics in some form was very much already around.
But I doubt that Aristotle could understand Eudox's theory of proportions. It's quite delicate.
Yeah, but I don't know. I think he could. He discusses actually that. Okay,
of course he can discuss it because it is philosopher. But to understand the theory of proportion, it's very delicate. Actually, there are some
right. But
for example, the rules when the triangles are similar, when the признаки подобия, what is called in Russian, it's book 6, yeah.
Right, exactly right.
It's not in 1.4. It's just because you need proportion.
Of course. All the theory of proportion in book 6, right?
Yeah, but for example, the rules, what is the area of a parallelogram is in book the first group. Yeah, it doesn't use proportions.
Right.
Yeah.
No, at least it doesn't use the area as well. Yeah, but what we can naturally interpret as area, it's there, right?
Yeah, and stereometric books,
and
they exist or not?
Just before.
That's not the end.
The most difficult book. I should confess, I did not read it all. It's actually the largest book, which is about half of the whole thing. No, not half, maybe 1/3 of the whole thing. Is book 10, which very interesting. In the very beginning, it kind of breaks this rule of keeping geometry and arithmetic aside, right? Because he involves this strange notion of having ratio as number to number, right? For geometrical magnitudes, which is commensurable more or less the same thing, right? And so here in book 10, you have kind of, in a sense, mixture of this geometrical theory and the arithmetical theory. But basically, it's what today we would call irrationalities.
But it
Because-
exists in Mordechai Baltovsky or not?
Of course.
It is already, yeah. Just
Right. So it's the most. He has this notion of being commensurable in degree. For example, if you have diagonal of a square and side of the square, right? They are not commensurable, but they commensurable in degree, which means that double square is commensurable with square.
Mhm.
And then you have other things. So it's quite.
Yeah.
I did not actually see the precise kind of mathematical analysis. I think that's also it's very delicate, probably the most delicate book. And then right, you have stereometry, which use all of that, which uses, of course, proportion. The last proposition is actually also a problem, is not a theorem, a problem of 5 Platonic solids, and then he calculates all these ratios between their volumes and some right. We can look. Okay, so that's no okay. Maybe before still we are here. Okay, I'll say very quickly what I want to say, and then we may comment, because I have something to comment also on definitions, postulates, and axioms. Yeah, but you should stop me, because otherwise I never stop. That's my
No,
favorite.
just that.
Okay.
Let's.
Right, it's enough. So there are two types of so-called propositions, and actually this word proposition is not even there in Euclid. I think it's right. Here is my Euclid definitions. You see, here they are just numerated. So that's when we say proposition, it's kind of it's not what we see, right? And it's not exactly proposition, because say theorems could be called proposition in logical sense, right? Something that evaluated as true and false.
Yeah.
But on the other hand, this, for example, is a problem and not proposition, which at least I think that's really important. It's not evaluated as true false, right? When you say to construct equilateral triangle is not something true false, right? But interestingly, that both propositions and both problems and theorems, they share the same structure, which is a kind of, carry over.
Yeah, but since we are here, just a technical question. So there is a picture with Greek letters or with Latin letters. So in old manuscript, the pictures were there.
No, there is no
or
picture.
They were.
There were no pictures. There was this letter notation, yes, but no pictures. And
but who produced the picture?
Yeah,
Heiberg?
actually, this I forgot his name. The second pupil of Sabbatai and Guru. Nets. Shamefully, don't remember his first name. He made a very good book. It's called something like Sharping Deduction in Greek mathematics, and he really studied that question. So they produced it on the sand, during. They never kept it in a kind of fixed written forms, these diagrams.
But in Heiberg, they exist, the diagrams, or not?
That's a good question. But anyway, they were added much later. They were added, I think, in Renaissance or something. So, right.
No, because I noted that it exists, except for this edition, in all other editions, I think the figures are just reprinted from one book to another, because they share the same, they look like the same file. So I thought that somehow historical pictures taken from somewhere, but
no, actually, at least one reason was that all this, not even printing, but kind of handwritten, right, kind of techniques, writing techniques were very expensive because material was very expensive. And so they would certainly not use this pergament or whatever for diagrams. And on the other hand, I think it's kind of also important, this idea of diagram as something, momentary, right? It's something that just you do along with your reasoning. But let me, because here I just made this. Right, so we have this actually 6 parts. 6 parts, they are described in Proclus, but it looks like it's not just kind of analysis, right? External analysis, but indeed in text, we do have the 6 part almost without exception for all elements. So first is in Latin, it's propositio, right? Or in Greek, it's protasis, enunciation in English. So you just say construct equilateral triangle, right? Then there is this important part, exposition, expositio. And then you say, let AB be given finite triangle. So maybe, Sash, you correct me. I think it's what is called existential instantiation, right? Then you
just show all the parts before.
Yeah. So that's and actually diagram shows up here at that step, right? Where you come from just general proposition about it's supposed to be universally quantified, right? For all equilateral triangle. It's not proposition
for all straight lines.
Right.
Yeah.
But then you say let
still
AB be this particular straight line.
But at that time, it's illogical to draw the circles. It would be natural to draw on, because the circles are part of the solution, not part of the statement, no? I think
no, you see, here in the case of problem, it's not clear because it's a problem to construct something, right? So construct means, okay,
let's see later what happens.
Right. So at that second stage exposition, you kind of individuate that, but actually you also analyze it into what is given and what you want to produce. You see? So that's just refers to part which is given. You individuate part which is given and which is AB. Next stage, you individuate again what is you want to do.
Required,
Right. So there is that's called dierismos in Greek, it's specification. So what do you want to do? Then follows construction, right? And construction is just and where you apply postulates, because postulates are constructive principles. They're kind of basic operation that you take for granted. So here you have your circles. Right. Then, of course, that's already was in antiquity that people noticed that nothing actually guarantees that they intersect. It's kind of gap in this proof. Okay. But importantly that, okay, you finish construction. You want to say I'm done, right? But not yet, because then you need a proof that you really constructed what your enunciation, right? What it says you.
Why the construction?
So it's kind of double thing. You see, you construct and you prove. It's double thing, right? And here it's well known. Here you use definition, and that's, by the way, one of rare definitions which is systematically used in proofs. That's just definition of circles. You say, okay, 2 radii equal, and hence by axiom 1, 2 things equal to the same thing. Then it's all equal.
Kolya, you had some questions. Sorry.
And what's the definition of equilateral triangle?
All sides equal. Nothing special. Sorry?
What does it mean that 2 sides are equal?
It is basic notion which isn't explained.
Okay, let's I finish this
then
part.
You need some postulates about that.
You
there
have
is a
axioms about
postulate,
that, basically.
some kind of postulate. For example, there is the postulate when if you can superpose them on each other, they are equal. And
Right.
it's never explained what is meant by superposition. It's something which never mentioned anywhere else.
Right, right. No, by the way, important, they are not triangles by trilaterals, literally, right? Трехсторонники.
Yeah.
Okay, okay. Yeah, so, and then conclusion, like sixth part. But now let's look into theorem. It's actually, I think it's the first theorem, because then you have only problem, and that is theorem about the angles at the base of isosceles triangle. But what is interesting, it's the same structure, right?
No,
you may say, okay,
I think the previous theorem, there's a previous theorem, which is признак равенства треугольников. I guess, no?
Yeah, thanks, thank you.
Yeah.
Right.
Okay.
Absolutely. We are going to use it. Yeah, right.
Yeah.
Okay. Yeah, but what is interesting is that it has the same structure. I don't know if there is any logical explanation. I'm thinking about, as I say, Cary-Horvath corresponds and stuff like that. Of course, very remote, but it's looks like. So again, we have general proposition, general claim, right? Then we have again exposition. Now, what is given is ABC. By the way, this theorem is interesting also because sometimes it's claimed that Euclid actually wants to consider as a, say, as a available object something which is constructed already, right? But that's wrong, because here you have this isosceles triangle which was not earlier constructed as a problem. You don't have problem construct isosceles triangle, even if it's, of course, solvable easily.
Yeah, by the way, it's interesting to see, this is a very strange proof, which I never had seen before.
Yeah.
And the reason why you uses is, I don't know, maybe you will explain the proof at some moment.
Okay, I think I
let's look here. ABC is AB is equal to AC.
Yeah.
Then
so
what
you do
extend AF
extend right to AG and
G equal arbitrarily.
So
FB is equal to CG.
And then there are these pairs of triangle which are equal, right?
So AFC is equal to AGB because of two sides and one angle. It's previous theorem. So FC is equal to JB.
Right.
And angles are the same. Angles F and angles G are the same.
Right.
And then we apply again to triangles BFC and BGC. They have two sides and one angle.
Right.
And so they have equal angles B and C, which are complementary to our angles ABC and ACB. Very strange.
Yeah, and then finally you use the third axiom, right? That you need, say, angle ABC, it's just given by angle ABC minus
ABG minus BCG.
Right.
Yeah, you cannot use just the fact that the opposite смежный, the BFC, FBC is equal to BCG, внешние, external angles, because you didn't have the theorem, which is another story. It's later. So what is not clear about the theorem and why Euclid doesn't just say that take ABC and rotate it and apply AC to AB and AB to AC because it's the same angle, so they should coincide. And so the angles also coincide, because the same idea of application, moving one triangle in the position and applying to the other triangle so they coincide, is really used in the previous theorem. So it's obviously allowed. But strangely, instead of using it again, Euclid just makes the strange additional construction to
no, at least what Mordechai Boltovskoy says about that, and I think probably he says something similar, that actually Euclid normally does not use at all this kind of motions, and that's it. Theorem 1,4 is exception because he has no other way to do that, right? And here
Okay, but if you already made a sin, you can just make the same sin again. It doesn't change much your position. It's strange that you don't want to repeat it because it's okay.
Yeah, at least, but what I think it's also interesting. You see, it's then in the case of problem, right? We had a construction and then proof, which verifies the construction, right? And here, our somehow task is different, right? Where construction is not epistemic task. So we say its construction is auxiliary, да, вспомогательное.
Yeah.
Auxiliary. However, structure is the same. We have first, after this part, exposition specification, we have a construction and a proof. You see, so structure is just the same, even if kind of idea of what we do is different.
Yeah.
Right. So, right, that's for structure. And
no, finally, he repeats all the time. He repeats what was written in the beginning, I guess.
Yes, yes. And there is this kind of ending, which is not the same in case of theorem and problem, which is the very thing was required to show. By the way, this that everybody learns quaderat demonstrandum is a
it's just this thing.
Right, is a mistake, because here in Aristotle there are two different verbs. I can show you. There is roughly, if in Latin would be demonstrare and monstrare, как монстрация.
Yeah.
But at least in Aristotle, in Second Analytic, there is a whole discussion that is not the same thing. Deiknomy and apodeiknomy.
Okay.
Right?
Okay, he's philosopher, but still, what I think your theory about their desire to save the paper is obviously contradicts the fact that they all times they repeat at the end what was said at the beginning. Or maybe they just make in some translations they just replace it thus for etc. They don't print it again, but maybe Euclid also wrote this.
It's also interesting because you see, it's I even many years ago I published a paper in the Вопросы философии about that. That's kind of a repetition. Probably it's important because at least it's not this scheme that we just deduce from one thing another thing. You see, we put first what we want to prove and then we prove. While in this kind of ideal scheme how deduction works, we do it the other way around, right? And that's
but there is a cynical explanation of Leonia Levin, who explained that in American textbooks they need to be more expensive, so they should be longer. So they repeat each proof 3 times. First time they explain what they will do later and plan. Second, they do the proof, and finally they summarize what they have done. So but this looks like the same thing.
But that's actually how in American colleges every kid is taught to write essay. Sometimes write usually.
Yeah. Exactly. Yeah. That's it.
Right. No, so let me I open Euclid's elements, right?
Yeah.
Here I want, if I have some, 10 minutes, I will not talk more. Some just remarks about definitions, because I think interesting. And of course, it's true that there almost none of it is used. So if you want to make any sense of the definition, I think we should just give up the idea that definition is something to be used in proof. they may be
No,
kind of,
it's clear. You just have to study them and to remember the formulation
right,
and to
right.
repeat it to the teacher. But you never use it, so you don't care about what is written there. You need just learn it by letter.
Yeah, no, but one interesting thing, okay, there is a lot of things that's actually was in my dissertation in this Russian book. And I think I made an observation that I didn't see made elsewhere. And you see, for example, there is this classification of trilaterals, right?
Yeah.
And today we would rather say, okay, there is kind of general triangle, whatever, then we specify among them there are isosceles, and among those there are regular. And here is all the other way around. He starts, there is a
Disjoint classes. Yeah. That's
at
yeah.
first it's disjoint classes.
And they start from the most small class going.
Right, of the trilateral figures. Oh no, that's not the same. Right, he starts with equilateral, with regular, right?
Yeah.
Then he comes to isosceles, and finally to scalene, which is, by the way, in Russian we don't have this, right? It's not.
Yeah. No, there is a word разносторонний, but this is kind of exotic. Yeah. By the way, just can you show that 22 postulate 22 definition 22, and maybe you can say how it's in Greek. A square is that which is right angled and equilateral. And the Greek formulation, does it assumes that such a thing exists, or just it's if there is something which is right angled and equilateral, then it will be called a square, but we don't claim that it exists. Because if it exists, actually, you can derive the parallel postulate. So
interesting, yeah.
But
right.
but the Greek expression, does it say that it's some in English? It's somehow, I think it's assumed that such a thing exists. If it doesn't exist, you should say more conditionally that not a square is, but they should be if a square subby would be called a square or something. No. How do they say in Greek?
No. First, I don't think you can answer that question. Look into Greek. But if you look into Greek, interesting thing, for example, we see that his term for square is just a tetragonal. It's just a как четырехугольник.
No, but they also use quadrilateral. So, for example, there is quadrilateral.
Right. He used this kind of scholarly special expression, tetrapleuron schemate, right? For just general quadrilateral or quadrigonal, right? And that's gives impression that's kind of invented. But square is just tetragonon, which means literally simply for четырехугольник, как по-английски сказать, for angle.
And
you see, without specifying that it's so. No, it's
but
it's
he
a little
means
bit
square,
different issue. Right? No. It somehow reflects the idea that if you just want to think simply about four angle, right? Four lateral. First example you have in mind is just a square.
So it somehow assumes that square should exist.
That's good question. That's good question. I think so. It's this topic is called existential import. It's
okay, but why then that all the people who wanted to prove the fifth postulate, why they didn't use it? If it's already there in Euclid,
they were not as smart as you are.
No, they definitely know this.
No, really,
they
actually,
do all things possible.
Sakari actually knew that it implies fifth postulate, right? I don't know.
Okay.
Yeah, that's a good remark. I never actually was thinking about myself.
Yeah.
But I think that kind of naturally, at least there is this discussion on Aristotle, on his syllogistic, and I think it's consensus that Aristotle always has what today we call existential import. So when he has kind of implication, right, he assumes that what you have in
So you are not allowed to introduce a name unless you prove that the definition is non-empty.
It's
Or
not
it is
probably
not.
they didn't think about it. I don't know. I don't know. I don't know. I didn't see the discussion in Aristotle. But probably I did not look into. I think that kind of stuff was discussed rather by Stoics already. So probably maybe they just didn't think about it.
Okay.
But I think so. I think so. Yeah. Of course, if you want to classify figures, you want to believe that in some sense they exist. Otherwise, you don't have anything to classify. So, in a sense, it's a very perverse idea to classify.
Okay, but no,
that it does exist.
It's kind of
right. But no, and I don't think that kind of specific of Greek language has anything.
Yeah. Okay.
To add.
So we don't know what will Euclid answer if we say that. Do we know that square exists?
No, probably he would say, okay, as you say, this is for philosophers. They exist, they don't exist. We just
but then we can use it in the proof. So no, we cannot say like this. No. Okay.
Right, and that's but otherwise, which are interesting. Of course, it's this question of dimension is interesting, right? That you have a kind of topological dimension. So
no, this is not used. We can learn it by heart and forget about it. Not a problem. I think. No, it's interesting what you could think, but it's next layer of difficulty. We can.
But at least I know one proof where this definition of point is used, and this is in Aristotle physics, not in Euclid.
Okay, no.
No, okay.
Aristotle physics.
No, okay, we can skip it if you want, right?
Yeah.
Right, now to postulate. Here, I think, because of course, in a kind of a lot of rendering, you have this postulate rendered as propositions, right? Either existential or modal. Как можно при вот Мордухая Болтовского, in Mordechai Boltowskoy, we have this model rendering that say it's possible to, and that's, in my sense, I would say it's wrong or something, but it diverges from Euclid, and at least if you think how to think about that, say, how to formalize it, if you like, then there is a easy way to formalize it as a rule, not as a proposition, but as a rule. So you give 2 points. It's kind of operation, right?
If we look at 1, 2, and 3, it's just a allowed operation construction.
Right. Exactly.
But what is strange that then we switch to 4 and 5, which are completely different.
Yeah.
And without any explanations why they are put here.
No, again, some people say that 4 and 5 are kind of later edition, but of course 5, if you want, you may render also as a rule, right? So you get this construction, and then you say this intersection point is constructible. So you construct this intersection point, but that would be, I agree, kind of not very natural, of course, but still, it's interesting. And here, by the way, I have a maybe I ask you later, kind of question about logical question, not about right. Then we have common notion. Again, I think it's you may render these as propositions, of course, right? But again, kind of simpler way to do that is to see them as a rule of inference, so right, which you have 2 equalities, you derive the third one. At least that works for 1, 2, and 3 again, right?
But before we get forward, I just want to say that there is a difficulties with common notions and axiom, and postulates. So the problem is that the common notion use something which is called things. And actually, as people explain, in Greek language, there is no this word things. There is just something, just expression without this. But
right,
still,
no,
nobody
comment. Ну, по-русски, in Russian, I think we may also avoid saying things.
Равные
тому же, равны
между собой. But the question is, what is things? So you can, the simplest way, which is usually written in all the commentaries, that there can be angles, there can be line segments, there can be figures, then they are equal, means that they have the same area. But still, it's strange, because here the second thing they say are added to equal things. So if I think that some commentators explain that in Greek you cannot add something. They just say that if parts are equal to parts, then the whole is equal to whole.
No, what in Greek it says prostheta. It's like thesis. Ну, как бы, it's like put together.
Yeah, but the problem is that if we want to apply these things to angles, we cannot add angles because they don't give an angle at some point.
Right.
And so this is still, if you look at the fifth postulate, it says that then makes internal angles less than two right angles. So this what is written in parentheses, whole sum, is not Euclid, because Euclid doesn't allow to make sum of two internal angles. We don't have an angle then.
Right.
And so and sometimes Euclid adds even three angles. Not adds, but mentions that three angles are equal to other three angles, meaning in modern terms that the sum is equal. So,
but I think what you wrote, and I can actually, right? I can show. I think you are right. I think Euclid did get the same proposal, at least it's most natural. So basically, you don't need this algebraic closure for making this comparison. You say
no, no, that's indeed my impression. But first, it's quite radical, and second, it's strange that if it really has anything really reflects what Euclid thinks. It's strange that no of the commentary from which I have seen mentioned, because I think that what we should do, we should compare the multi-set of angles or multi-set of intervals and so on, and then there are then the Euclid's arguments become good, but not in the book on proportions. It's still again not completely true, because when they prove something about proportions, they see that they speak about between. They don't, when they say that if A has the same proportion to B as several A's to several B's, they write A and B as one singleton multiset, not the general case. So it's only locally consistent, and later it's not explains what he does later. So it's strange.
So now you're talking about definition of fifth book, right?
Yeah. So, but I guess that the fifth books, they should have the same when the construct ratios, proportions between angles, they also need to add them. So you have the same problem there. But strangely, it's not completely consistent.
Right, but no, it could be kind of difficulty, but on the other hand, no, as you say, it's consistent. So you don't need to think that two angles together is again an angle. You don't need to say that.
No, but then for the proofs, you need to consider this multi-sets explicitly sometimes. But what is more strange to me that there are several commenters on Euclid in English Commons and Mordechai Baltovsky, and even this later this Fitzpatrick, and none of them see the problem here. What is strange to me, because it's obviously a big unclear place, and they don't try to they don't say ask something here. Strange.
You should write a comment. Yeah, I don't know if anybody noticed that, because of course there are many comments.
No, of course. I guess that some Proclus or some. No,
probably not Proclus, right? Because
no,
mathematically you are right. Proclus is not very
no.
helpful.
I would say that Archimedes would be the person to ask, but probably he didn't write anything about Euclid.
Right.
But he knew about Euclid. In his books, he refers to Euclid, or not. So that he says, according to proposition 7 of 5th book, we know that blah, 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 or he never makes explicit references.
Let me. No, I don't think so. He makes. We should look. Actually, Archimedes is edited in Russian much better than in English. Say so. So we have all. Really.
And maybe even better than in Greek, but it's a bit.
No. There is a really
dangerous.
good edition by. No, I don't think he made this explicit reference. No, it's rather say this Arabic. If you find this in Arabic mathematicians, no, because for Archimedes, Euclid is just kind of colleague. People don't how say.
Okay, it's usually a good practice to reference.
I don't think they had it. Actually, there is no, of course, these internal references in Euclid text itself. He never says that's postulate 1, that's postulate 2. It's all added. You should guess that, right? It never.
And so, but when he wants to say that, as we have proven in some other theorem before, they don't give the number.
Says, no, and he even doesn't say. I think it's kind of let me just it just goes for granted, right?
So you should remember everything, so you don't need to.
Yes. So it's all added. You see, there is no in Greek text.
The CN and
yeah. So.
But when he refers not to the postulate but to the previous theorem, just
I think the same. There is no
for that
huge
here are added references, proposition 1, 8 and so on.
So you're supposed to remember. Yes. And so it's much later, because for these people say already in like 9th century, it's kind of big classics. And then you refer back and say otherwise.
No, so just we probably should finish at some point. But what I'm saying, that it's very interesting to look at these books, and it's maybe when you read some book, maybe you will be the first one who sees some strange things which they didn't see before, or just commentaries are missing. I don't know whether it's strange to me, because it should be already studied for centuries, and in 19th century, of course, they should somehow see this. Why they don't do this? It's
part of the problem, I think, is that really it's not so often that really mathematicians look into really old texts, you see, because it's more often that just mathematicians won't get some general idea and do their own thing. And also historically, if you like, it was always more or less the same. And so people who would be interested in kind of studying.
No, but there were students of Euclid. They could ask him, "What do you mean, really? Why they don't do this?" It's not clear to me.
But frankly, it's not the most difficult. It's relatively easy, because say if you take Archimedes or Apollonius, it's much harder. And in Archimedes, of course, it's just incredible mathematical, argument. It's
No, but mathematical arguments they are ingenious, but we know of them, so it's not something difficult now. But
no, say yes and no, because if you immediately translate it in kind of modern language, yes. But if you want really follow
the special details, one should try Archimedes indeed.
Yeah. Or I tried a little bit Apollonius. That's really kind of hard because how say no, that's completely different setting. So you should forget everything you know about like analytic geometry stuff. It's
no. Once I tried to read Almagest, which supposedly has the Ptolemy theory of universe. But the first part is just a lot of lemmas about spheric trigonometry. And to get the idea what he thinks about universe, for example, whether Earth rotates or not in his theory, it's not obvious. I spent an hour probably, but not more. But still, it's not obvious.
No, it's here he explained in the introduction that he kind of sticks to Aristotle. He doesn't really care about whether this epicycle exists or not.
No. But just the model which he considers: the Earth is moving or not, rotating or not. Well, I understand that it doesn't move around sun. The sun is moving around, but whether it rotates or not, it's not clear for me. But probably
rather not.
No, but I'm not sure, because if it's not, then the rotation of sun around Earth would be completely stupid. You cannot.
So it's heaven that rotates, like it's a sphere which rotates.
Yeah, heaven rotates, but then if the sphere rotates, then the sun is rotating with a very strange trajectory. So
right, of course. But then he had this method to describe this.
No, I'm not. So that's what I'm not sure. But one should look.
No, at least he would be completely open to option. That, yeah, that was this Pierre Duhem was a kind of philosopher, Catholic philosopher on the end of 19th century in France, who popularized Ptolemy's expression saving phenomena. And that's idea that you just make a mathematical model without going deep into kind of physical questions. Right. Yeah.
Okay.
So probably, maybe
we have
some
to
other
finish.
people also have questions, though.
Yeah. Let's ask whether people have questions. And I see that now we have only Russian-speaking people.
Да,
поэтому можно говорить. Если есть у кого-нибудь вопросы.
Нет, слушайте, вот может одну штуку, которую просто мы вот уже обсуждали, но может не все поняли, да, что такое равенство вот в этих теории 1-4 книги. Значит, это что-то, что можно перевести, так сказать, по объему совпадает с тем, что вот называется как та же самая...
Равновеликие.
Равновеликие, да. Но смысл тут, конечно, другой. Смысл это, собственно, задается вот этими самыми аксиомами. И это похоже, да, вот здесь вот это тоже такой тонкий немножко момент, что это похоже на равносоставленность, но
не обязательно, там есть аксиома про вычитание.
Вот.
Равенство по дополнению вполне законно для
А есть какое-нибудь слово, вот не равносоставленность, а так, чтобы вот с третьей аксиомой тоже? Или такое?
Равны по дополнению, по-моему, так называется. Равновеликий. Это надо посмотреть Гильберта в основании геометрии, там, по-моему, есть какое-то слово.
Ну да. Ну, в общем, вот в этом идея, что здесь... Равенство и конгруентность – это частный случай равенства, который вот как раз описывается.
Да, который никак не определяется. Просто говорит, что то, что совмещается друг с другом, они равновелики, так сказать. Это вот, и как-то это он совершенно не комментирует абсолютно.
Ну вот, да. И, конечно, в этом смысле, вот когда мы добавляем вот эту пропорциональность, это уже такая сильно расширенная теория.
Да, нет, там есть, это есть вот это учение Евдокса, оно очень интересное, что А относится к Б, отношение к Б – это множество пар тех целых чисел m и n, при которых ma больше nb. И, соответственно, пропорция А относится к Б равняется С относится к D, как раз состоит в том, что эти множества совпадают. И вот после этого можно попробовать доказать, что если А относится к Б так, как С относится к Д, то А относится к С так, как Б относится к Д.
Ну, вот он там
С
все
помощью аксиомы Архимеда он это делает. Но аксиому Архимеда он употребляет как-то очень так тихой
Нет,
сапой.
просто аксиома здесь, она не аксиома, она здесь часть определения. Нет, почему?
Нет,
Потому что
правильно,
там
но в
все
этом
просто.
определении... Нет, ну, это не... Нет, это часть определения,
Ну
но
да.
там есть, например, теорема, что если А относится к Б, если А к Б равно С к Д, то А к С равно Б к Д. И
Мгм.
там совершенно про А и Б это может быть верно, что они сравнимы, а про А и С может быть неверно.
А,
Поэтому
да,
тут
кстати,
так
да.
тут нельзя рассуждать. Поэтому, в
Кстати,
общем,
да.
тут какая-то у него есть... Нет, он в некотором месте даже явно пишет, что возьмем такое кратное, которое больше другого отрезка. Причем совершенно не объясняет,
Мгм.
почему это можно. А до этого, наоборот, он объясняет определение, что две величины имеют отношение, если некоторое кратное одной больше другой и наоборот. То есть тут какая-то тоже у него какая-то ерунда. Вот непонятно, что он имел в виду.
У него это у кого? У Евклида?
У Евклида.
Да,
Искал мне
это...
элемент Евдокс.
Так
Нет,
это, ну,
нет, а мы
авторы
не,
Вдокс, а...
нет, вроде бы, но это не сохранилось. Я как понимаю, сохранилось только вот в виде евклидового изложения.
Да, да. Ну, как раз это, по-моему, очень считается надежно, вот история про Евдокса. То есть
Нет,
там сомнений никого.
имеется ли оригинальное сочинение Евдокса на эту тему или нет?
Не,
Все, что
не,
мы
не
знаем,
думаю, не думаю, надо посмотреть. Ну, может, какие-то где-то фрагменты, что-то, но
да,
таких вот книжек это Вдокс точно не осталось.
да, да. Нет, это, в общем, как-то история математики очень такая удивительная наука.
Вот
Там
это,
столько...
знаете, теорема такая, что не могут окружности больше, чем в двух точках пересекаться. Вот это такая отдельная тема, интересная, как невозможные конструкции. Вот он
Да.
предполагает, что в четырех и дальше там.
Нет, но почему обычное рассуждение не проходит, что если пересекается в трех точках, то тогда серединные перпендикуляры проходят через оба центра, а они различные. Почему нужно какой-то... Вот обычно в
Может, просто
школе
другое
так...
доказательство, да? Может, просто другое доказательство.
Да нет, ну это надо посмотреть.
Да, надо посмотреть.
Это я не видел. Да.
Тут, самая вот трудная 10-я книга. Вот если у вас есть кураж, вот попробуйте в нее посмотреть.
Нет, но я уж в первой ничего не понимаю, о чем мне десятка.
Э, Ну да. Ну и,
Саш,
конечно, вот эти
Да,
стереометрические тоже
по-моему,
интересно.
если не копаться в этом самом, в точных определениях, а апеллировать все-таки к интуиции, по-моему, ну, это замечательно совершенно, потому что происходит действительно реальное доказательство, ну, в том смысле, что убеждающее. И,
нет, но в некоторые моменты, некоторые рассуждения, вот, например, вот имеется теорема, что сумма двух смежных углов равняется двум прямым. Казалось бы, что тут доказывать? Они просто вот, и они образуют вместе развернутый угол. Но, тем не менее, Евклид проводит некоторые специальные доказательства. Он там применяет свою теорему, там, аксиому про равенство и добавление, разбивая там на три угла. Спрашивает, зачем он это делает? То есть вот у него есть какая-то внутренняя логика, не сводящаяся к тому, что наглядно объясним.
я
Ну,
понимаю, да, но некоторые вещи можно игнорировать в этой книге.
Нет, нет, ну, конечно, вообще вы можете не читать.
можно и
Но
не...
интересно, что он себе думал. Был великий человек, он, наверное, имел что-то в виду, не просто он так
Мне вот, слушайте,
написал.
у меня вопрос вот к логике,
Да,
такой пример. Но вот смотрите, можно действительно по-разному это вот формализовать, или что же делают, да? Один способ такой, грубо говоря, гильбертовский, то есть мы заменяем вот на такие экзистенциальные аксиомы, то есть мы забываем всю эту историю конструктивную, что там какие-то процедуры, вот,
да,
значит, это один. Другой способ, вот такие тоже, кстати, есть, не очень давно разные попытки, но вот попробовать это в таком как бы генсеновском стиле, да, с помощью набора правил формализовать, что вроде как ближе, так сказать, к оригиналу, но вот дальше вопрос, вот в каком смысле там это может быть эквивалентно, не эквивалентно, ну даже если вообще отвлечься от Евклида, вот пускай у нас есть система правил, причем правила, они вот не обязательно логические, да, они могут быть вот как у Евклида, так сказать, геометрические, что из одних геометрических объектов строим другие. То есть они не обязательно вот как устроены как правила вывода, но тем не менее вот формальные правила. И
Нет,
система
я думаю,
там
что тут нужно, это так нельзя ничего сказать, надо какой-то пример иметь. То
конкретно. Ну
есть
да,
так, в таком в
ну
общем
и
виде
может
я не
я...
думаю, что есть что-то такое прямо
Ну
можно
есть вообще
переводить с
какие-то вот
какого-то.
общие теоремы, которые, ну грубо говоря, вот говорят там стиль Генсена, стиль Гильберта, да, у нас либо там много правил, нет аксиомы, или
Нет, но
много...
и в том и в другом случае у нас там скорее все-таки утверждения, а не конструкции. То есть это про другое.
Ну,
Нет,
немножко про другое, да.
нет,
Да.
ну так сказать, если говорить поверхностно, то, что вы говорите, напоминает скалимизацию. Мы переходим от утверждения, которое с
Мгм.
квантерами, к утверждению, ну, для всех существует, переходим к утверждению там а от x, f от x. Вводим функцию. Но это я не думаю, что
Ну
тут
да,
что-то
это
есть
совсем...
интересное.
Ну да.
Вот.
Нет,
Нет, в
скорее вот
общем,
меня интересует переход вот от системы правил, да, к системе, ну, правила все равно хоть одно нужно, иначе мы ничего не выведем. Ну вот, грубо говоря, вот этот вот генсеновский там, то есть в каких-то случаях там можно, вроде известно, что это одно и то же, да, там вот можно ну, логику представить, либо там
нет, ну да,
дифференциальные исчисления, но это специальный случай, а вот в более общих случаях ничего такого не работает,
я
правильно?
не знаю, нет. Но это как-то, мне кажется, что надо иметь какой-то пример более
Ну
конкретный,
да, да.
пытаться понять, с
Ну
чем
вот,
оно. Да.
вот и Евклид как раз, да.
Ну, и Евклид понять даже так нельзя, а чего уж тут.
Да, да.
Вот. Хорошо, ладно, значит, в следующий раз давайте мы, сейчас уже пора кончать, потому что у нас тут скоро, если я опоздаю на обед, меня расстреляют на ужин. Но, значит, я чего хотел сказать, что на следующий раз у нас вроде бы предполагается доклад студента, знакомого Казачинского, про схемы реализацию majority, большого majority с помощью маленьких, с помощью, ну, вот изучения сложности этого вопроса. А, значит, 15-го может рассказать Томас Штайфер про что-то такое, тоже автор Казачинского. А 22-го или 29-го может рассказывать Глеб Новиков про свою деятельность в Цюрихе. Вот. В общем, это, пока еще это будет все написано, но если есть другие желающие сделать доклады, потому что это все так пока предварительные договоренности, если есть какие-то другие доклады на эти числа, то это тоже было бы хорошо для разнообразия. А
Ну,
то как...
значит, надо нам выслушать Тимура Купцова все-таки, хоть это и будет скучно, потому что для него надо устроить предзащиту, его магистерской диссертации, ну или дипломной работы, проще говоря.
Да.
Ну вот,
Нет, но если так, нет, если это он не от этого не повредится, и это административно необходимо, то это надо устроить.
ну да, ну так что я не знаю, он готов, в принципе, и в следующий раз рассказывать, но
Хорошо, ладно, тогда обсуди это с Казачицким, насколько он договорился с этим студентом, и, может быть, тогда действительно надо это самое его слушать.
Слушай,
хорошо.
а я буду, вот это до меня дойдет, ну, может, я за что-то добегу, если я там что-то буду понимать.
Нет, в смысле объявление, вы хотите получать объявление?
Да,
Тогда, тогда, ну, это вы
это
сами
типа,
можете, я включу вас в список.
спасибо,
Да,
хорошо.
да, 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 нет, но там это будет совершенно техническое, там будет там это самое,
Ну,
булева схема, сложность, там то
ну
все, то
да,
есть
да,
это, но, так
понятно.
сказать, нет, объявление, мы с
Ну, может, что-то,
удовольствием,
если будет
нет,
интересно.
нет, мы будем очень рады вас видеть, просто
Я
такое
бы...
предупреждение, что, так сказать, что
Понятно, понятно.
nothing guaranteed, нет,
Хорошо, хорошо,
будет
хорошо.
что-то неизвестно что.
Хорошо.
Вот хорошо,
Слушайте,
спасибо
а вообще,
большое.
вот я просто понимаю, вот этот семинар, то есть здесь вот часть людей, вообще люди географически разбросаны
Нет,
совершенно
но это
везде.
раньше когда-то это был семинар в Москве, который
Ага,
основал Колмогоров. А потом
понятно.
все разъехались, пришли новые люди,
Ну,
там
ясно,
это
ясно.
самое. Вот
Да.
откуда, например, пришел наш сегодняшний заграничный гость, я даже не знаю. Я никогда не видел его фамилии, имени, но
Да.
why not?
Ну, слушайте, большое спасибо, да, что
Нет, вам
пригласили. Очень
спасибо.
интересно,
Это
да.
самое. Ладно.
Вот. Ладно, все,
Всего
счастливо.
хорошего. До
Счастливо, всего
свидания.
хорошего, до свидания.
Значит, просьба всем выйти, потому что я в прошлый раз не вышел, из-за этого записалось гораздо больше, чем надо.